Hi, my name is Steven, and this is my final project on Scenic Morphing. So the goal of this project is to take several images and blend the images together to make it seem like a smooth video. Now, I have 8 images of a tree's foliage taken from behind the window frame, and each image was taken from a slightly different direction. So you can see that the window frame in each image is slightly different. So if I were to naively blend the images together, that would make the window frame shift around throughout the video and it would look very choppy. So the goal is to align the images first and then blend the images. Thus, my approach consisted of 4 steps: resizing the images, doing image registration, where I align the images, then cropping the resulting images to get rid of any um, boundary issues, which I'll talk about later. And then the fourth one is to just image morph, otherwise known as just blending the images together. So first I'll talk about image registration because my approach to image registration actually led me to need to resize the images to a fixed size. Now, if you don't recall from class, image registration consists of finding the key points of each image and then calculating the homography matrix and then warping the perspective of one image to match the perspective of a different image in order to align all the images. So the first method I tried was scale invariant feature transform. And I did this because I wanted to just use an algorithm to automatically calculate the key points for me. However, this did not work because the images have a decent amount of color variation and noise because of the tree's vibrant colors. In this image, it's just in grayscale, but you can see that the key points don't line up in between each image. For example, this green line, clearly this key point here should not match up with the one over there. Now, this inspired me to my next approach which is sift with a mask, where I try to mask out the background tree and just focus on aligning the windowsill itself, right? So this method, I said, okay, it's not with sift by itself, it's not checking the windows, it's not calculating the key point at the windowsill um, enough. So let me just do a mask to mask out the background, and hopefully it will find the key points on the window frame. This did not work either, mainly because if you look at the mask in this picture, there's still certain parts of the tree that have grayish, whitish pixels. The way I calculated this mask is by giving a value of 1 if the pixels 3 color channels were similar to each other, and I gave it a 0 if they were different. Thus, it would mask out colors like red or green, but it would leave in colors like white and gray. However, these image pixels were gray for the trees in certain areas, so the SIFT algorithm just calculated those to be the key points, and SIFT with a mask did not work either. So in the end, I just chose to do manual selection. This meant that I needed to resize each image to a 720 by 960 for manual selection. And I chose 5 key points per image for all 8 images. So the next step in image registration is to calculate the homography matrix and then sort of realign the image by warping them. Um, and how I did this is I calculated the homography matrix between each subsequent image and the first image, rather than calculating the homography matrix between each consecutive pair of images. The reason I wanted to do this is because if you calculate the homography matrix of each consecutive pair of images, and there's slight deviations in between um, the alignment for each image, the errors made in the very beginning would propagate downstream. So I want to align each image to the original image. So if there were any slight deviations, it would only affect one of the images. So this is just a quick slide going in detail on how I calculate the homography matrix. And as you can see from this bullet, I warp each image to match the first image. The homography matrix is calculated using least squares algorithm using the key points that I found using the slide here. And um, the prime images, the prime pixels was image, the original image, image number one, and then each subsequent image was X and Y on the right-hand side on this column. So now I've warped all the images. You can see that the window frames for each image are in the same position for each image. However, you can also notice this issue where there's some blacked out pixels. And the reason I have this is because when you warp the image, they can no longer some of the images, some parts of the image are blacked out. So that leaves black space in the corners and the borders of the image. And this actually happens because I resized the images to a fixed size. So now all of these images have black space. And previously, if I were to resize the images after warping, then this issue might not have occurred. This only occurs because I had to resize it at first in order to actually manually select the images. However, there's a very simple fix. It's just cropping the images so that you can get rid of the border for each image. And I just did this by finding the maximum top left corner and the minimum bottom right corner and just cropping out the same image for each of the 8 images to get my final 8 images. You can see it's lined up very nicely. And yeah, the next step is blending or image morphing. And I do this with linear interpolation. So I take each consecutive image pair and I linearly interpolate the pixels using a space of 30. So I take 30 frames per 2 images and I just linearly blend them. And the result, I put in 10 frames per second just to show a more gradual change. So I have 240 frames. You can see that the window lines up throughout the video, and it's really just the tree itself that changes. The lighting changes and everything, but that's intended. We just want the images to be lined up well. So for next steps, I have 2 main steps. The first one, the most pressing next step, is to create a scalable method for registration rather than manual selection. The reason for this is right now, resizing and choosing the images manually. One, it's not very scalable for larger scale videos. If I were to do this for 100 frames, 100 images, it would have taken forever. So you need a scalable way to calculate the key points. The second reason for creating a scalable method is reducing the loss of information from resizing. Currently, I resize the images to 720 by 960. So I lose a lot of image from resizing. And if I can just find a scalable way to do it, I don't need to resize it because the only reason I needed to resize was so that I could manually select the key points. And then the second step is exploring advanced blending methods or more advanced blending methods. So I could try a method like sigmoid, for example. But that's less urgent because linear blending seems to work fine. And it'll just be a matter of changing the algorithm for blending it. Um, and yeah, that's my presentation on scenic morphing for my final project for EE332. Thank you for listening.